All right, so all year long, we've always done a function and then the inverse, and a function and inverse. So when we talked about the quadratic, the inverse was the square root. And when we did the cubic, and the inverse was the cube root. So we just finished with the exponential. And this is what the exponential growth looked like. And it went through that point right there. And we had the asymptote was y equals 0. Right? So if I wanted to talk about the inverse of the exponential, first of all, what would happen with the asymptote? If I have to switch the x and the y equals 0 will become x equals 0, right? So that means the asymptote would have to go this way for this one. And then, if I know this point is 0, 1, what point would be on the inverse? Not negative, but we would switch the x and the y. So it'd be 1, 0, which would go right here. So the log is going to look like this, the inverse of the exponential. So if we fill in, on the exponential, we had y equals 0. On the inverse, we have x equals 0. If the domain was all real numbers and 0 to infinity, if I'm switching the x and the y, then the range is going to become the domain, right? The y's will become x's. So this is 0 to infinity, and the range will become all real numbers. We switched them. Okay, then there's a bunch of words. Okay, then we get to the part that we're going to learn. Okay, so all of the words, though, it really is telling you why you have to do this, and like who uses this. And believe it or not, they actually use logs for many things. But you will use this for the test. And I don't want to hear about, you don't care about them. You're going to use them. And we're having fun. And you're going to like this because this is way easy. So, I want to start with this right here. I'm going to start with example 2. So, we're going to read that log base 5 colon of 25 equals 2. Log base 5 of 25 equals 2. Now, if I want to write that in exponential form, so there's a lot of technical math ways I can show you how to do this. We're going to call it the circle thingy. All right? And the reason I'm going to call it the circle thingy is because I can show you how to do it. You'll never be able to do it, but you'll remember circle thingy. You're going to come up and ask a question, I'm going to go circle thingy, and you're like, oh, yeah, got it. All right, so circle thingy is really a technical term, but watch. I'm literally drawing a circle. See that? I went 5 to the 2 equals 25. I drew a circle because the log base 5 of 25 equals 2 is 5 to the second equals 25. That is its exponential form. Okay, we're drawing the circle thingy, okay? That's what we're doing. And so what you have to remember is this number right here is always the base on the log, okay? And the number across from it is the exponent, and this number always is right next to the word log. So if I want to write this in exponential form, again, the circle thingy, so I'm going to get 2 to the negative 2 equals 1/4. That's it. Is this true? 2 to the negative 2. So the negative means it goes to the bottom, and second means you square it. So 2 to the second is 4. So I get 1 over 4. So if I write the circle thingy on this one, x to the 4th what is x in this case, by the way? 3, right? X equals 3. So if I rewrite this one, so the circle thingy is we're changing from log to exponential form, right? Log to exponential form. Now, what if I want to go back the other way? I want to write the log form of this. So I already know before I start what's the base from here. 3, right? So the 5 and the 5, those are the bases. So I have to write log base 3. And then ask yourself, if you're going to draw the circle, what goes on the other side? The 2 goes on the other side, right? So the 2 goes on the other side, and the 9 goes here. So nobody's going to miss these because you can double check every time you write it down. Is it right or is it wrong? So the next one, what's my base? So log base 4. What goes on the other side? Oh, yeah, negative 2. And the 1 over 16 goes here. 4 to the negative 2 is 1 over 16. Go.